After you open your Gridline 1 elevation view, let's change everything to solid, transparent main so we can see the connections. And first let's zoom in here up at the top here to this bar joist. You'll see that the bar joist still only shows up as a single line. Again, SDS2 does not detail bar joist, so it does not show in solid. A couple things I want to mention here is, as we zoom in here, here's on this column there's this plate. That's that stabilizer plate that we added to the bar joist when we were in the bar joist here. Stabilizing material, we said plate, and that's the plate that SDS2 created for that bar joist. On the other end of the bar joist, when it frames to the column, right now there is not a connection. We're going to come back to this connection in a little bit, so we'll skip that for now. The beam here, we looked at that on plan view. That's good. So here I'm going to do all solid, and this beam right now has failed, so I'm going to hit process here, get it back so it's back to solid, but the beam has failed, and it should be failed on your model also. So let's double click on that beam, or that vertical brace I should say, and we'll see that the load here, we need to change the load. If it's on auto, yours probably reads 68.3. So to change that connection, let's change our load here from auto to 40 and hit OK, and then process. Click anywhere on the screen, it should refresh your model, and we can see it still failed here. So we'll double click on it again, and let's scroll down to the bottom, and left hand limit state, it's saying the supporting member web stress value is 12.6. So let's change this to 10 for the load and hit OK. Process. And now we have a connection. Now what you can see is what's happening is, because of that load, we've got 4 bolts here. On the other end, we left the load as it was, and we've got 6 bolts. So again, here's a situation where if the engineer gives you the loads, you'll have to go back to the engineer and ask him to come up with a connection for you. If he doesn't give you the loads and you lower the loads to get the connection to work, again, you should have the engineer verify that connection. So Gridline 1, that brace there is working. It may not look exactly like your drawing S3 as far as the number of bolts. The bracing up here, we have connections on all locations. Again, this connection with this beam and this joist up here on Gridline B, we're going to come back to that one. So let's go now to stay on your sheet S3, and let's look at your Gridline 1, Gridline 2. So let's open 2 and look at that. Let's start up here at the top. We have a connection here for the brace, another connection over here for the brace, so that looks good. One reference here, when we put in this slope beam, and remember when we put in these beams on the opposite side here, we said web normal. Now that everything's processed and connections are there, you can see the beam on the far side is, the web of that beam is perpendicular to the top flange. It's following that on all 3 locations. The bottom of this brace here, connections there, bottom of that one connection. This vertical brace, we have that connection, and the bottoms we have connections. So all of them vertical braces look good. Flip to your next sheet, S4, and we have grid line A, so let's open up A. And let's start here. You can see we have our brace here. It has connections both ends. On the opposite side, connections there, both ends. The tube steel bracing coming down here, we have connections here, but on the top we do not. So let's look at this connection here. If I double click on this brace and scroll down to the limit states, it says supporting beam must have clip angle, shear plate, and connection. Now the beam we said was failed also, so let's look at that. Double click on that, and it says slip critical bolts required for slots, oversized holes. So let's go scroll back up towards the top. Under our connection type, we've got auto standard. On our bolt type, we have A325N. So let's change them to A325SC. Let's do it on both ends. And hit OK. And let's process. Click anywhere on the screen and still no connection. So now let's double click on our beam again. Scroll down. It says required bolt diameter is greater than maximum available. So now on our loads, scroll back down to our loads. On our loads, let's change the load here to 10 and hit OK. Process. Still no connection. So another option here, if you are not getting a connection, is to change the bolt diameter. Let's just bump it up here once to 7/8 on both ends. And process again. Still no connection. So in this situation here, we have quite a bit of stuff happening. We have the joist coming into the column, this beam coming in, this brace coming in. So here, let's try forcing it to reprocess everything. So let's put a crossing box around and hit menu OK, or menu and then mark for processing. Process all members, create solids. And still nothing. So now let's go back to the brace. And in our setup, I believe we probably have the setup so it's transferring some of the load of that brace into the beam. So this brace has a quite large load on it. Let's knock this down to 20 and 20 for the tension and hit OK. Now let's process. And we still have nothing. Knock it down to 10. I'm going to try the other brace right away. Go back to process. Still no connection. on our plan view, we're asking for a shear bar connection. So I'm going to change that to shear and shear. And hit OK. Process. Okay, so in this case here, the auto standard, it did not like the auto standard connection because of the framing situation. So in this case here, by changing it to shear and telling it what to use, it worked around the problem and gave us our connection. So that's another thing to look at, is change your connection instead of leaving on auto standard. Go back and change your connection to a different type of connection. Another option was to change the bolt size, diameter, and then lowering the loads. But again, all these options that we're going through are for demonstration purposes. You need to have your engineer look at the connections if you are changing them from the design parameters. So now we have that bracing working. So now let's go to grid line B, and that's on your sheet S4. And all we're going to really look at there is, again, we looked at this previously on that moment connection here. We had that working on the other end. We had the welded moment working. Okay, the final thing, if you remember, we had this bar joist here, and the connection I said was incorrect. So this is the bar joist on grid line 1 and B. So I'm going to zoom in here, and I'm going to show you a couple of things here. First of all, let's zoom in and hold on your shift key. And again, if you hold on your shift key, your middle button will be the rotate. So hit down the middle button, rotate, and you can rotate around as you move your mouse here. And here's what the problem is. It has a connection there. It's a seated connection, has a plate. But here, if I rotate a little bit more, you can see that plate interferes with the bolts. So to solve that problem, I'm going to rotate back around to where we were. And now I'm going to use my surface commands, my surface mode over here. I'm going to select the web of this beam. And then let's zoom in. Let's hit escape. Your button bindings here tell your options here. Let's hit escape to get out of that command. And then I can use my pan button to pan around, scroll back in. So to change this connection, we'll double click on the beam again, and our connection is on auto standard. If I scroll down, keep scrolling down, and you'll see the information for that connection. So my clip angle, near side clip angle, so this clip angle here, here's the information for that. And you can see everything is grayed out. You cannot change this information as it is right now because it's an auto standard connection. So what I want to be able to do is drop this clip angle down so it does not interfere with that bolt. So my clip angle information here, as you look down here further, you'll see vertical to first hole, 3 inches. That's a AISC standard that we follow. If I click on the unlock button and lock this, I'm going to lock it at 4 1/2. Now that's for the near side clip angle. the far side clip angle, if you scroll down further, here's the far side clip angle information. And vertical to first hole, 3 inches. Click on that file cabinet and lock it, or I mean the lock button and lock it. Change that changes that to 4.5. Now I'm gonna hit OK. And I'm gonna process. Click on the screen anywhere, and that connection dropped down. But for some reason, I lost my connection on my bar joist. If I look at my bar joist, it still says I have a connection on my right end of my bar joist. That would be. It still says seated and plate, but for some reason, the connection disappeared. Previously, we tried to force it to reprocess, and it still didn't work. I'm going to put a box around here. Process, mark members, and process. Click on the screen, it does not show up. What I found is if you go back and change your connection from a plate, let's change it to a T, hit OK, process, click on the screen anywhere, and now the connection reappears, but we don't want that T connection, so now let's double click on that bar joist, change it back to a plate, hit OK, reprocess, click on the screens anywhere, and now our connection is back. There must be a slight bug somewhere in the programming that is causing this, but that is what I found to get the connection back. So now going back to our isometric view, and if we rotate around that and zoom in there a little bit further, and I'll rotate a little bit more, now you can see there's definitely no interference with that connection. So that takes care of all the connections on the project, and that will end this demonstration.